MS2 check हो गए machine learning के टू
yes Manish.
MS2 मैम जो दिए थे वो पेपर हुआ था 28 अप्रैल को चेक हो गए
हाँ बिल्कुल हो गए
चेक हो गए पेपर ऑनलाइन
हो गए बेटा ये
नंबर पता नहीं
okay so next I'm going to start with this clustering method. So anyone who can first tell me what is clustering? Yes Shivam, can you unmute and tell me? Okay, so I'm going to start with this. First thing is that unsupervised learning. So already we have done that. What is unsupervised? In case of unsupervised learning, you have been given the data that is unlabeled. So what's the meaning of unlabeled? Target variable is not there. Okay, it is not given in case of the fruit, like example that you are taking, it has not been given that depending upon these features, whether your fruit is of type mango or apple. You just have been given some features. Depending upon those features, you have to identify whether it belongs to the cluster 1, that is apple category, or cluster 2, that is the mango category. Fine. So it will categorize these different data set depending upon the features, depending upon the similarity among the features. So organization of unlabeled data into similar groups, they are called the clusters. Fine. So within one cluster, you are having all the data items. Why? Because they are having something similar to one another, and they will be dissimilar to the data items in another clusters. Why? Because their features don't match. That's why they are put under different clusters. Like you take this example, suppose this have been given to you. You just have been given some data points. Okay. Now, if you will do clustering, since all these blue points, they are having something in common, they will be put in one cluster. All the red data points, they are having something in common, some features, similarities there. They will be put in another cluster, and third cluster would be of this type. Okay, that is green in color. So you have not been given that what is the value target variable for these features. You just have been given the features. Depending upon that, you have to put them into different clusters. Like I will take one example, like the example that you have taken of fruit, that was very simple one. Now this example is that suppose like there is a store and they are having suppose lakhs of customer data is there. Okay, now they want to like improve their marketing strategy. Depending upon that, like in order to improve that, in order to increase their performance, they want to categorize their customers, that what is their purchasing habit. Depending upon that, they want to categorize that. Okay, one way is that if they want to make any new marketing strategy, if they want to impose some new business rule, then we will have to go through the details of each customer, and accordingly we can suggest some policy that for this customer, this marketing strategy is good. Okay, for another customer, this is good. But if customer data is very large, if you're having thousands of lakhs of customer data, it is not possible to go through each customer details. Okay, for that, we can use the clustering. Suppose I want to say that I want to make 10 clusters depending upon the purchasing habits of the customers, like whether the customer want to buy during the sale period or during the discount period or not. Okay, depending upon that, suppose I want to make 10 clusters. Okay, so once you are having the 10 clusters, we can make a separate strategy for those 10 groups instead of making the strategy for different customer. So in these examples, you can use the clustering, that if your data set is very large and it's not possible to go through each and every data set, we can do the clustering. Depending upon the clusters now if you are having 10 clusters, then that means all the customer in cluster 1, they are having the same purchasing habit, and all the customer that are in the second group, they are having same purchasing habit. So we can plan a different marketing strategy for these customers and different strategy for these customers. Okay, so this is one example where you can use this clustering technique. Now, what are the different types of clustering? You're having different types of clustering techniques. Like one is hierarchical clustering, that is also called connectivity based. Next is called the partitioning methods. These are also called centroid based. Then distribution based clustering is there. Then density based is there. Fuzzy is there, and the constraint based. Okay. Out of these, you are having these 3 in syllabus. These 3 were written in your syllabus: hierarchical, partitioning, and the density based. Okay, so I will be taking all these 3 types of clustering. So first of all, I'm going to start with, this one, centroid based partitioning. Okay, so first of all, I'm taking the partitioning method, that is the centroid based clustering. Okay, this one. Centroid based clustering, or this is also called the partitioning methods. Okay, the meaning of this will be cleared once I will take one example, but I will just go through these points. Centroid models are called iterative. Why these are called iterative? That thing would be cleared when I will be taking one example. This is called iterative clustering algorithms, where similarity between data points are derived based on their closeness to the centroid of the cluster. Okay, so this is very important, that whenever you want to find out that whether a data point, it belongs to, suppose, this cluster or this, it will be based on what we will do. We will find out that what is the center of this. Okay, centroid means you can say you find out the average of all these data points. That is the center of that. You will find out the center of this and the center of this one. Suppose there is a new data point and I want to find out whether it belongs to C1, C2 or C3. I will find out what is the distance of this data point from this cluster, and this one. Since the distance from, suppose, this data point to C3 is minimum, I can say this data point belongs to cluster C3. Okay, so that's why these are called centroid based. Centroid means we need to find out the centroid, center of each cluster. So what is the center? Center, you can say, is the mean, average of all the data points. Then whenever you want to find out that whether a new data point belongs to cluster C1, C2 or C3, we will find out the distance of that data point to all the centroids. Okay, depending upon the minimum distance, the centroid is found, making sure that the distance of data point is minimum within the center. Fine. Now, the algorithm that I will be taking for this centroid based algorithm is called K-means algorithm. And this is very important one. So under this centroid based, I will be taking K-means algorithm. What's the meaning of K and what is the meaning of means over here? Again, I will come to all these slides again once I will take this example. Okay. Here K means that the number of clusters that we have to form. Okay, and we need to give that thing. So that is actually the disadvantage of this algorithm, that before starting the implementation of this algorithm, we need to find out that how many clusters we have to make. So K is representing the number of clusters. If you are saying K is 2, then your data points would be divided into 2 clusters. If you are saying it is 3, then your data points would be divided into 3 clusters. Okay, so K is the what? K is the number of clusters that you have to make. And what's the meaning of means over here? Means represents a centroid of a cluster. Mean means average, mean. But here I'm using this word means. Means this is the plural form of mean. Why? Because we need to find out the mean or the cluster of all the clusters. That's why we are using this word means over here. Okay, So that is the meaning of k-means algorithm. So again, I'm going through this. It is an unsupervised learning algorithm which groups the unlabeled data set into different classes. So here K defines the number of predefined. So this word is important, predefined. Predefined means before actually starting this algorithm, user needs to give the number of classes that we have to create. If K is 2, there will be 2. If it is 3, there will be 3 classes. Next, means in k-means means arithmetic mean. We need to find out the average. Fine. And it represents the centroid of a cluster. This is okay. Next, I had told you this is an iterative algorithm. Iterative, why? Because it will run for more than one times. This algorithm we need to run for more than one times, and then it will go on. There is one termination criteria, so that will be cleared once I will take the algorithm. So I'll come to this slide again. So let's first take, I will come to this algorithm, okay? First I will take this example, then only this thing would be clear to you that what's the meaning of this k-means. Okay, first of all, suppose these data points are given to you, okay? So in k-means algorithm, first of all, I need to decide that how many clusters I have to make. Suppose for this example, I'm saying that I have to make 3 clusters. So what I have decided? I have decided that the value of k is 3, okay? So if k is 3, that means there are 3 clusters. Now, what I will do, I need to decide that I need to take 3 centroids. C1, C2, and C3. So initially, I need to initialize the cluster centers. Cluster centers means centroids, okay? Now, these 3 centroids can be any 3 data points. Like you can pick this data point and you can say this is C1. You can pick this data point, you can say this is C2, or you can pick this data point, you can say C3, or it can be any new data value. Suppose over here, you can say when value of X is 2, suppose, and when value of Y is suppose something 3.9, this is your centroid C1. And the when value of X is something suppose 1.4 and C2 is 2.5, that is your centroid C2. Okay. So first of all, I need to take 3 data points. Why I'm taking 3? Because I have already decided that the value of K is 3. After deciding the value of K as 3, I need to take 3 centroids. And again, I'm repeating that these 3 centroids can be 3 data points that are already given to you, or it can be some new data points. Anything you can take as the 3 centroids. So here I have taken, suppose, 3 new data points as 3 centers, C1, C2, and C3. Fine. Next step. Now, what is the next step? I will find out what is the distance of each data point from C1, C2, and C3. How to find out this distance? That I will tell you later on. Distance means I will find out whether this data point is similar to C1, C2, or C3. Like right now, you can say this is more close to C1, so this is of type C1. So I will say that this belongs to C1. Similarly, I will find out for all other data points. I will find out whether this is similar to C2, C1, or C3. Now the distance of this is very less from this C2, so I can say this belongs to C2. Similarly, this one, this is more close to C2, I can say this belongs to C2. This is more close to C3, I can say this belongs to C3. Okay, so this way I need to find out the distance of each data point from all the 3 clusters. And depending upon that, we need to decide whether a particular data point belongs to C1, C2, or C3. Okay, so if you will do like this, next is this one. That means 3 clusters would be formed. Now, all these data points, they were more close to C1. So I'm saying the orange one, these are in orange in color, they belong to C1. All these data points were more close to C2. So I'm saying they belong to C2. And all these data points, they were more close to C3, sorry, this one. So a third cluster is formed. Okay, any doubt so far? Then I will take one numerical also related to this. Is it okay? What I have done, first of all, I had decided the number of clusters, that is K value. Then I had selected 3 data points or 3 new points as 3 cluster centers. Then I found the distance of each data point from these 3 clusters, and depending upon the minimum distance, I have decided whether this data point will belong to C1, C2 or C3. Okay, any doubt over here? This is okay? Okay. Next step is very important. Now just see, when you have decided that all these belong to C1, you are having one cluster over here, second over here, third over here. Now again, you will find out that what is the centroid of this, because obviously now the centroid of these data points will change. Now centroid means you need to take the mean of all these data points. So obviously mean won't be this one. Mean would be somewhere over here, because more points are close to this point. So C1 value will change. So C1 will come over here. Similarly, C2 will change. When you will take the average of all these, mean of all these, C2 will change. C2 value will be somewhere over here. And even the C3 may be somewhere over here. So C3 will change. Okay. So next step is that you need to recalculate the value of C1, C2, and C3. Once you will do that, okay, C1 will be more toward this side, C2 will come to this side, and C3 will come to this side. You can see over here. Okay, C1 is changed, C2 is changed, and C3 is changed. This is okay? Okay, now, after these centroids are changed, now it may happen that some of the data points that previously belonged to C1, now they may belong to C2. Like right now, I'm taking this data point. You can check that this data point is orange in color. Previously, it belongs to C1. Why? Because it is more close to C1 than as compared to C2. But now, again, I want to find out that whether this data point belongs to cluster 1, 2, or 3. For that, again, I need to find out the distance of this data point from all other centers. When you will find out the distance, you can see now this is more close to C2 as compared to C1. That means I will say this is in green in color. This belongs to C2. Okay, that means the cluster value of this will change. Similarly, you will do this thing for all other data points as well. You will do for this also, for this also, and this also. Is it okay? So once you will do this thing, you can see previously it belonged to C1, that's why it was orange in color, but now it belongs to C2. Why? Because the distance of this is very less from C2 as compared to from C1. Okay. Once this is done, this is the second iteration now. Again, obviously now again the centers of some of these data points are changed. So centroids will also change. So again, you will find out the new centers. So C2 may change over here. C3 will come to this side. C1 may come to this side. Okay. So C1 is over here, C3 over here, C2 over here. After this, again, the third step is there. Again, you will find out what is the distance of each point from C1, C2, and C3. And accordingly, if the centers of any data point is changing, you will change that. Again, you will find out the centers of the new clusters. And this step will go on until there is no change in the centroids, or there is no reassignment of these data points. Suppose right now you are saying all these belong to C1, they belong to C3, and they belong to C2. Okay. Now again, I'm finding the distance of these points from C1, C2, and C3. Suppose it is saying it belongs to C2. All these data points belong to C2. That means there is no reassignment. The cluster value of these data points are not changing. The cluster values of these are not changing. And the cluster values of these are not changing. If there is no reassignment, that is the last step. Okay, so in last, you can say all these data points belongs to C2, they belong to C1, and they belong to C3. That is the last step now. Okay, so this is the basic idea, like how this k-means algorithm is working. Any doubt in this? Because then I will go through the algorithm. There are many other things, like we need to decide how to take the distance, how to find out the value of k, optimum value of k, how to find out that. Then I will take one numerical also. Any doubt over here? I won't ask you any question. If you have any doubt, now you can write down, Shivam, in chat box if this is cleared or not. Yes, Nitika, Manpreet Kaur. Yes, Manpreet, you got 20 marks out of 24. 280 roll number. Can you tell me, is it cleared? Yes. Sorry. Okay. Now I think if I will go through this now slide, now this thing will be cleared. Okay. What is written over here? It is written that it is an iterative algorithm. Now I think this is cleared why this is called iterative, because we need to run this algorithm more than one times. That divides the unlabeled dataset into k different clusters in such a way that each dataset belongs only one group that has similar properties. So that thing is already clear. So k-means algorithm partitioned the data into k clusters. Like in my example, I had taken k is equal to 3. So my algorithm partitioned the data into how many clusters? Into 3 clusters. And each cluster is having a center that is called the centroid. And these are the main things that is written, that k is specified by the user. Fine. So that is also clear that k is specified by the user. Like here, I had specified that I have to divide my data set into 3 clusters. And main aim of this algorithm is to minimize the sum of the distances between the data point and their corresponding clusters. So I think now this point is also cleared. That main aim of this is that the distance of any data point from its cluster should be minimum. Okay, if this is more close to C1, then it will belong to C1. But if this is more close to C2, it should belong to C2. So that is the main thing over here. Okay, now I think you can put that example in the form of the algorithm. I think only 2 minutes are remaining, but anyway, I will go through this. Then again, I will take this algorithm. That first of all, you need to select the number k. K is the number of clusters that you have to take. So that is okay. Next step was that we need to select random k points, or we need to select k centroids. So in my example, first of all, I had decided that k is 3. Next step was that I had selected 3 centroids. I had selected 3, C1, C2, and C3, 3 centroids. Okay. What was the third step? Third step was that I had calculated the distance of each data point from all the 3 clusters. Okay, if any data point is more close to C1, I'm saying this belongs to C1. So next step is that assign each data point to their closest centroid, which will form the predefined K clusters. After finding the distances of each data point from all these clusters, we are calculating the new centroid of each cluster. Okay, and we need to repeat these steps until what? Until there is no reassignment. So repeat the third step, which means reassign each data point to the new closest centroid of each cluster. And if any reassignment occurs, then go to step 4, otherwise finish it. That means if there is no reassignment, then that is the endpoint. Okay, whatever clusters you are getting, that is the final result. So again, next time when I will be taking this, again, I will repeat this algorithm.